Hi everybody, my name is Nerly and I'll be doing this mesh current method problem from exam 2. The problem states that we should write a complete set of mesh current equations that could be used to solve the circuit without simplifying the circuit and not solving for any of the equations that we come up with, and to label our mesh currents clearly. I went ahead and labeled each of my mesh currents ahead of time to comment on the fact that you could label your mesh currents going in counterclockwise direction as well. It's just personal preference, but I do suggest that you label them all in the same direction, regardless of what direction you go to. Whatever you wish to do. So first I'll begin with I1, but we see that we have a current source in between I1 and I3, so we will have to perform super mesh. There's two things that we'll need. We'll need the constraint equation for this current source, and we'll need a super mesh equation going all the way around while removing this current source and its respective resistor. So the constraint equation is as follows. We have I1 going against the current source, so we have negative I1 plus I3 is equal to 75 milliamps. Positive I3 because it's going with the 75 milliamp source. Now we'll need to perform the super mesh equation while removing the 75 milliamp source and its respective resistor. So we'll go ahead and begin in this corner here and work our way all the way around. So we have I3 times 89 ohms, and then we're met with the negative terminal of this dependent source. Moving on to the 61 ohm resistor, you want to write the beginning of this equation as seen by this current, I1. So I1 minus I2 is the current going through the 61 ohm resistor. And finally, we have the 92 ohm resistor. So I3 minus I2 times 92 ohms, all equal to 0. Now we can go towards I2. We'll start in this corner and work our way all the way around. So first we're met with the negative terminal of the negative 2 volt voltage source, followed by I2 minus I3 times 92 ohms, plus I2 minus I1 times 61 ohms, plus I2 times 33 ohms, plus I2 times 46 ohms, bringing us back to the beginning, all equaling to 0. So now we can move on to I4. We'll start in this corner and work our way all the way around. First, we have I4 minus I6 times 60 ohms, met by the positive terminal of the voltage source. So positive, negative 2 volts. And now we're back at the beginning of the loop, so that will equal 0. Continuing on to the I5 loop, we see that there is a current source in the middle. So we will need to perform super mesh as we have done for I1 and I3. First thing you want to do is come up with a constraint equation. So we have I5 going against IS1. So we have negative I5. And then I6 going with IS1. So positive I6 would be equal to IS1. And now we need to perform super mesh by removing this current source and building a loop around I5 and I6. So we'll begin in this corner and work our way around. First, we're met with the 34 ohm resistor. So we have I6 times 34 ohms plus I6 minus I4 times 60 ohms followed by I5 times 58 ohms, and then positive 38 volts is all equal to 0. Now we see that we have 1, 2, 3, 4, 5, 6 equations, and we have 6 variables that we're trying to solve for here. Our 6 loops, 1, 2, 3, 4, 5, and 6. But we have 2 extra unknowns, IZ and VX, that we need to solve for. So we needed an additional 2 equations to completely solve the circuit. So we'll start with IZ. And since we're using mesh current method, we have the ability to use I3 and I4 to solve for IZ. So since I3 is going with IZ, we'll get positive I3, and I4 is going against IZ, so we'll get negative I4 is equal to IZ. Followed by VX. To solve for VX, we'll perform a small KVL here, labeled A. And we'll begin in this corner here. And we're met with negative VX first, plus the 46 ohm resistor times its respective current, which is I2. And then we're met with a voltage source with its negative terminal first. So negative 2 volts. And now we're back at the beginning, so that all equals 0. And now we have 8 equations, and we have 8 total unknowns. So this problem has now been solved for what the problem statement asks. And yeah, thank you.